Hello, Ajit. Welcome. Niranjan Khatri here.
Very good evening. So, with that note, I think we can start the session now. It's already. So, I will just take a couple of minutes to introduce Ajit sir. I'm sure, many of you already know him and his work. He's a marine engineer by training, and he has spent over 35 years and another 40 years in marine thing as well as in environmental solutions, DEWATS sessions, which he will be sharing with all of us. He has been closely associated with leading institutions like CSE, and where he has contributed extensively to decentralized wastewater treatment practices across India, and his work bridges between engineering, ecology, practical implementation of such technologies on the ground. Uh, and So that's about it. So with that note, I won't take much time. Over to you, Ajit sir, and we can start the session now.
Good evening to you all, and salutes to all of you. We are all senior veterans. I know you've got so many years of experience, and I would be able to draw a lot of lessons also from you. But from whatever modest experiences which I have gained, I'll be talking about it. Mostly, it will be practical experience because all the 20 plants which we have done, it's all done by me and by my team. That's an NGO, Vigyan Vijay Foundation. I think I'll straight away start with the slides and slides so that it'll be easy to explain.
Sure, sir.
How? Yeah. Okay. Today I'll be talking about the DWATS. The DWATS means it is actually full form is Decentralized Wastewater Treatment System, and I'll be talking about septic tanks, and the septic tanks will be adapted type. Septic tanks adapted means they will have their flow, upward flow, and from left to right, right to left. There will be baffles in the septic tank, and there will also be uh, separations in the septic tank to have filtration. You will have big boulders, something like 6 inches stones, and next will be something like 1 inch, 2 inch stones, and then last we will come to this half-inch, this rubble, which we usually use for RCC roof and all that. That will be the stones which we will be using, and it will be this septic tank having all these things will be followed with a simple, you can say, a collection tank where we will try to get in the gray water in case gray water is there in the campus, and after it is equalized over there, then we will take it to the phytoremediation plants, phytoremediation plants, and I will be mainly concentrating on giving you the hydraulic retention time. Hydraulic retention time in this septic tank and in the phytoremediation and in the equalizing tank is very, very important. And no doubt, whenever we do this DWATS and DWATS wastewater treatment system, the space occupied will be a bit more. That is, for example, if you have a 10 kl flow, 10 kl sewage plus sullage, gray water and black water, I'll say half and half, or sometime you can have it something like 1/3 black water and 2/3 gray water. So this division would be there, and this combined water, whatever is the flow, that would be one standard, parameter. So that is the flow per day which we will take it. But sometime what happens, some persons, they say they are very, very clear about using and segregating the gray water, so they will use bioenzyme. So when they use bioenzyme in all the water washes, See, in any campus or any homes or any complexes, we have a lot of washes, and mainly washes are done by using water. So in water, they use soap. Instead of using chemical soap or strong, say, alkalis and all these things, we try to go in for bioenzyme. When you use bioenzyme, that whatever is the effluent, whatever is the wastewater which come out from the system would be quite friendly, very, very friendly, and they don't require much great treatment. Of course, they have to be equalized and they have to be remedied using plants and some other, say this either stone filter or whatever we can have adapt in that. So we use say about two-thirds of the HRT or two-thirds of the tank for these phytoremediation. And I will be explaining that phytoremediation. If possible, we will try to keep it in floating bed type. Okay, this is my first slide in which I have explained you that the DEWATS principle which we would be going in is a totally and naturally assisted, naturally based type of a solution. What is a usual jargon which everyone uses, NbS, NbS. So this is totally an NbS, and you don't require any uh, any power. Main thing is all the hydraulic flow, water flow, all flows by gravity, and we will try as far as possible to keep 1:100, 1:100 gradient flow for sewage. And in at times when it is difficult, we would like to keep it 1:50, and more than that is not required. So in any campus or any complex, easily these tanks can be made out. And one good advantage is, no doubt, they say that DVATS occupies a lot of space. But if you plan the tanks and the layout very well, these tanks can be made, and all these tanks are underground. All these tanks are underground, and we limit the height. We limit the height of the tank to around 2 meters, 2 meters or 6 feet height, and so that on top of the tank, on top of the lid of the tank or the roof of the tank, we will leave about 6 inches, 9 inches in the ground level, so that the tank is located 2 meters and a little bit more than 2 meters below the ground level. And on the ground level, we will be able to put 6 inches of 6 inches, 9 inches of good bud, imported from outside and with a lot of manure, and you can have a total greenery. You can have total greenery. But some people, they are short of parking space and other things, so they make properly, well laid out, compacted, very firm roof of the tank, so that cars can be parked. Of course, very, very heavy trucks and all these things, they will not be allowed in that area. But generally, cars and even bigger cars can be parked in those areas. And all that is required on the top of the tank is manhole, and certain vent holes would be there. Certain vent holes in the beginning of the tank, in the middle of the tank, and in the end of the tank. Certain vent holes will be there, and certain, you can say certain telltale holes which will be there. For example, in CSE we punctured holes on the top of the tank to have experiment how we can extract sludge from the bottom of the tank using a hand pump. So we tried that also, and that also worked. So that in rural areas where you find difficulty in man entry and other areas because of shortage of space, we can lower a India Mark II pump, slightly modified India Mark II pump, and sludge can be easily pulled out from the septic tank, the last stage, last sump. And so bottom of the tank also is done in such a way that it is sloped. It is sloped in a way that it is going towards the outlet side, and we have the flow inside the septic tank. We use baffles. Left to right, the flow will go. Then other part, it will go from the left, and from the right to left, left to right, again left to right. So there will be baffles done in the septic tank to do this partition. I mean this lining up of flow, and will be using mostly upward flow. That means there will be pipes leading the inlet water, inlet effluent right into the bottom of the tank, and then it will rise up. It will rise up by its own head of water, and it will go into the next baffled space, baffled chamber, and it will go from left to right, right to left, left to right, right. So all this say conductivity with the tank, conductivity with the filtering media is all very, very helpful. Very, very helpful. Nigarika, next slide, please.
Yes, sir. Yes, sir.
Please, next slide.
Yes,
Okay,
sir.
so this layout of this outline of this my presentation, I'll have how do we have the basics of account of wastewater from varied uses. That is very, very important. And this will be a cyclic process. That means we'll have water, or whatever is the pure water which is coming into the campus. It is becoming dirtied. It is becoming dirtied by human intervention. That means you've got sewage being flushed out in the toilet, and you've got all the washings, say your bathroom washing, your laundry washing, your kitchen washing, and any other washings from laboratories and others. Certain spaces we would like to be very, very cautious. For example, laboratories and other clinical areas where the water are coming out, we don't like to lead it directly into this DEWATS plant. We would like to pre-treat it and then send only the water. So this process is tabulated, and DEWATS project concept I'll be explaining. Then I'll be explaining the various DEWATS components. DEWATS component, I will be taking one role model because you all know the organization Center for Science and Environment, started by Anil Agarwal ji in late 80s, and then of course Sunita Narayan ably has carried forward after his demise, and since nearly for around 30 odd years, 35 years now, from 1990 till now, they have been doing excellent work, and they picked our DEWATS and DEWATS type of principle to be used so that everyone can be explained. More than the project doing the remediation of water, this project went into a research mode. That means every time, whenever some inlet water is to be analyzed, we'll have laboratory samples being taken out, or after a couple of baffles in the septic tank. I mean, say how we will take out the sample and pull out the parameters with the various physical, chemical, and microbiological parameters in the wastewater, and see how remediation can be improved, in how filter media can be increased, can be decreased, or some other flow characteristics can be increased. So we had this trial, and a lot of R&D. I mean, typically a lot of research and development went into it, and Center for Science and Environment, I should be thankful, because whatever is the experience which we had gained, of course, it was quite troublesome for us, because every time we would be called to modify the flow, modify some component, and many things. but it is all come in a good way. And after it has been used for about nearly 5 to 8 years. So this was set up in 2004 2005. So after about 8 years, 2012 2013, they were setting up Anil Agrawal Environmental Institute, Anil Agrawal Environmental Institute at Nimili, a place in Alwar district, and that has got all models of rainwater harvesting, wastewater remediation, solar panels, and many other things. So that was this our model was taken up, and the modified, or you can say more perfected version of our model was used at uh, at their plant at Rajasthan. And so they were also conducting residential courses, and many have taken the advantage. Government officials, semi-government officials, corporate officials, and NGOs have taken benefit of the training, and a lot of trainings have been done at some very substantial cost and substantial rates also. Okay, and then I will be explaining on the hydraulic retention time in the various components. And then, of course, last two slides will be having the way forward and what all has happened from since 2005 onwards till now, till 20 years, what all are the development which we'll be able to talk about. Then we'll be opening the floor for questions. Okay, next slide, please. Okay, now we'll be having very clearly, of all of you know that we have very clearly to account for the wastewater being generated in any site. So site, whatever is the site, it could be a housing complex, or it could be a organization, or it could be an industrial complex with having only say people using in the toilets and other washes. So or it could be a unit having some restaurant or some cooking units. So all this has to be properly tabulated. So this wastewater per day, it comes into two categories. So that everyone knows about these two categories. One is the black water, which is the sewage. So that has been put on the left hand side, category 1, and category 2. I think those people who have got bigger screen, maybe a little difficult to read in the mobile, but I will be able to explain you. Category 1 is the wastewater from sewage, and nearly in a house or in a housing complex, which we'll all be dealing with, 1/3 of the water which is being supplied. We'll take it as units of say data, 150 liters per person per day, GPCD, and this will be dealt properly with the sewage treatment plant, and properly this will be called as a septic tank. And we have got the second category, which has got the bulk of water. And here the advantage comes into the complex, those who are using bioenzyme. So if you already have, say the water is become organic, the whatever is the wastewater is organic in principle. So it becomes easier. It becomes easier, and you can have sacrificial. You can have first stage sacrificial plants to take care of remediation of water. Second phase to do slightly more remediation of the grey water, and last phase can give you the very good remediation. So whatever is the BOD and your all the TDS and many other say contaminants in the wastewater can all be brought to the complaint level. Of course, you cannot bring it to the reusable level, but you can always bring it to a level in which They can be used for secondary uses. In the complex, that water will be fairly clean and clear to be used for flushing toilets, and it can be clean and clear to use for gardens. So because it's already rich in organic and say organic ingredients, so you will find that water is really good for plants. So we'll have something like the outlet will be limiting to around 30 ppm, around 30 ppm. Next slide, please. Okay, this I'll be explaining to you the cyclic process. Yeah, as a matter of fact, everyone knows the cyclic process of any process which happens in a naturally based solution, or you have got some solutions aided by machines and men. So what happens is, first is a natural resource. It can be air, it can be water, it can be any other thing. It can be a proper thing in environment. Now you have a human activity. This cycle is a main cycle which is usually explained in the second year of environmental science. So human nature and activity, whatever is a natural resource. For example, water. We dirty the water. We dirty the water by putting sewage water and flushing it. So sewage water is coming in, and then it becomes waste water. And if you are able to take care of this waste water by a directional activity, by using an STP or a cleaning mechanism. For example, if it is a grey water and you got mildly polluted water coming out from various washes, they can be filtered. They can be remedied using either nowadays you got phytoremediation. The word spelled with T, phyto, is using plants. And the next one is there, you have phyco. I mean, you can use algae. Algae and algae material also can be used for remedying wastewater. So both these are used for remedying water, and you can, if after it is remedied, you can call it as a forced activity, forced directional activity. Then the water returns back to fairly a clean and clear stage, not as pure as rainwater or as the pure water which you got, but you can usually fairly keep it as for secondary and other uses which can use it, so that conservation of water can be possible. So this and in the right hand side, I got the same process being explained in a flow chart. Cyclic process, a conversion of naturally based solutions. Water from toilets goes through the DEWATS principle, and it is all coming out, and it's got both secondary and tertiary process, and you have fairly clean and clear water which can be used for gardening and various other purposes like your floor washing, and certain waters, if it is properly done with the good filtration, can also be used for industrial purpose. For example, you got water for say radiator cooling in a building, another that water can go and be cleaned up and used for such uses. Okay, next slide, please. Okay, this I've got one of the sites in which uh, the right hand side has got a picture showing phytoremediation using Canna indica plants, and of course it is also explaining the total project and project concept. Now this project which we had done is in a children home. There are around 100 to 120 children, say boys from age of 5 year up to 20 years. They are staying in the ground floor, first floor, and second floor, and they are all mostly. I mean, very very sad to say, they are orphans. and they come under the patronage of SOS, Save Our Souls NGO, and they that 100 wards staying. They have a kitchen, and they have toilets, and they have got various other normal uses, and they are attached to a school, and there are around 10 odd very very serious. They have gone to an engineering college, and they are studying in an engineering college, and they are waiting for some placements to be done. So usually after placements, they are released after getting placements in engineering college or in any other say profession. When they come on their own, they are released from the old age, from the youth home. But till that time they stay. So we have got this 5 KL per day is the flow. So we have got the 5 KL per day. So we have got quantity inflow. The inflow, after it is balanced, the water inflow is around 200 to 300 ppm, and it is processed, and we have got the process done in the primary, secondary, and tertiary. And in the next slides, I'll be briefly explaining you how we have coined, how we have literally formed up how much of flows are done, so that if anyone wants to have some thumb rule of some calculations, you can easily do in a home. Anyone has got a plot, and he's got a separate say sewage and sullage coming out in a plotted home, not in flats and community having a multi-rise building and all that. Even multi-rise building, all this thing can be done. Only thing is, the both black water and grey water requires to be separated. And if the whole community is able to uh, devotedly use bioenzymes for using for water and water washes, it will be very good. It will be very good. Okay, next slide, please. Okay, now this I'll be explaining to you the actual flow. See, what happens is, we have got around 10 odd components in this whole STP. That is all totally, it is all, you can say, cement masonry type of construction work. So first one is a directional chamber, and this directional chamber is given in twin basis. That means one directional chamber is used for one day, and it is changed over to the next directional chamber in the next day. And this directional chamber will be able to have some filtration, big screen filtration to filter out, and also any plastics and other things coming as a floater. So the contaminants in the water come either as a sinker, which is sinking with a heavy density, or as plastics which are coming out, and they can be pulled out from the top. So each day one tank is changed over. So when you have this changeover, so one full day the other tank is being taken up for cleaning and maintenance when the flow is going on in the first directional chamber. And then you have the number two. Number two will be the settlers, and we have got settlers into three sections, and we'll have about 9 chambers. So we'll have got something like 2 and 3. Both these are they have got pure dump. Initially we have a dump tank. Dump tank means the tank is don't it does not have any filter media in the tank. And the next chambers, it will start having filter media. So as I mentioned to you, we'll have three levels of filtration. That is stones of around 4 inches, 5 inches, 6 inches, that is 150 150 millimeter size stones, 100 to 150 millimeter size stones, river stones will be put in the first phase. Then comes around say 25, 30, 40 say sized 1 inch to 1 inch, 2 inch, 3 inch maximum stones in the second stage. And the third stage, last stage, will be the rubble which we usually use for putting for any RCC work and others. Something they call it as Rodi, that is half inch or around say 15 millimeter, uh, 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 15 millimeter in size, and they are all these are required to be taken out once in 3 years. So once in 3 years, we have a shutdown of each chamber, one part by part we can do. So we can take out the roadie, clean it up, and put back on the side of the tanks. We could have places where it can be used by jet. These stones and all these things can be cleaned and maintained. And then we have the last one is 1, 2, 3. These are all the tanks with either dump tank or simple tank or with filters. Then we have a directional chamber. That is number 4 will be a directional chamber where again we can do sampling and other things. And then the water turns around and comes to the phytoremediation, that comes to the plants and plant usage. The first phase of the plants are growing in their own beds, going in the normal beds. And the next, where the water is becoming more and more clean and clear and more pure, the water is kept in the floating way. So the floating beds are used. So floating beds can be taken out, and when we use elephant grass or Canna indica, these are the plants which have been used. Initially used Canna indica, uh, that is called a keli in Hindi. A kela, it is a plantain variety kela, and in Hindi it is called keli. In Tamil and Kannada and other, it is called kal vaazhai. Vaazhai is a term used for plantain. So that is used. But now we are changed over to fodder, a type of grass. Elephant grass is used. Elephant grass grows well, and elephant grass can go and with that whole bed with the grass, say grass grown after it is put in the bed, say 6 inches, 6 inches 6 inches tall grass goes up to about 4 feet. That 4 feet grass is taken out and kept for cropping, and it can be used for cattle or goats or other things. So then this water, you got this. It's called, you can call it also a reed bed treatment. After that, we take it for an equalizing tank. 9 is a equalizing tank as a processed water, and 10 is a final tank where we have the water coming and it's been pulled out. In that tank, some of the clients they have managed to get some extra say resources, and they have done some aeration. So aeration and other things, so that also helps in making the little bit of gases which is still remaining in the water can come out, and the water gets duly aerated or oxygenated and well done for using for all the secondary uses. Okay, next slide, please. Okay, this is for those who are having a little bit of mind to know about the design and other part. For example, if you have a flow, let's say if you have a flow of a 10 kl per day, 10 kl per day uh, in the complex or in the campus. So now we'll have HRT. So usually HRT 10 days is quite a lot. 10 days is quite a lot, and even 5 days is enough. 5 days is enough for a good treatment. But if you are able to give more time, it is always better for say purification and also for cleaning up the water. I mean, even I would like to tell you some more things on the home front. For example, when you have an RO filter or an AquaGuard filter in the home, this is nothing to do with a DEWATS treatment. It is totally a small experience which I've learned. Suppose you have an AquaGuard in the home. Now, if you have a trickle flow means the flow as less as possible, and time consumed is maximum. That will be the best, because water flows in a very low flow rate, and all the water which is flowing in the chambers go through very nicely, and certain say a cleaning mechanism, for example, the cleaning mechanism which we all should hope to do it very well is the UV mechanism. For example, the UV mechanism, it takes a very long time for the water to pass, so it kills all the bacteria, virus, and all the E. coli. Everything is all done nicely there in the UV filter. So you make sure that even in homes, whenever someone says my AquaGuard, I can fill up 1 liter in 1 minute. No, it should not be. If you take 1 minute for 1 hour, I mean say 1 liter for 1 hour, it is very good, because the maximum say residential time or maximum time the water goes through this UV rays, it is the best for the thing. So you can keep a note in case, and we'll be able to ask. I mean, you will be able to ask questions, and anyone who is say authenticating this principles of using long time for better cleaning and purification can watch for these principles and practice. Okay, so now I'll go for this. So whatever you have is the 100% is the including the HRT. So pre-process chamber, wherever any process is there, we have something called as a pre-process say mechanism. So that this pre-process mechanism is the directional chamber or a big screen filter, and that is given in the twin basis, so that one day one is being used, other days in other filter is in cleaning, and next day it is changed over. So this is done, and its flow, that means the tank capacity would be about 3 to 5%. Then comes primary, secondary, and tertiary. This I made it very simple. It is kept as one third, one third, one third. That means it is kept as something like 30%, 30%, 30%. 30% for primary, 30% for secondary, and 30% for tertiary. For example, if the sewage and sewage part of the water is very less, you can drop down. You can drop down this 30% to 20%. And if the gray water is less, you can drop down the last 30%. So 30, 30, 30 can be altered. The last comes reuse of process. This is again the water after it is totally purified and cleaned and made clear. It is stored. You have a 1 day storage. 1 day storage in the for all the processed water, and that water which comes, all the flow and all the say the mechanisms, it is all by gravity. It's all by gravity, and we use 1:100, 1:100 the flow characteristic. And at times, whenever you have this thick sewage or any pulpy matter coming out, so we use 1:50, 1:50 gradient. Otherwise, 1:100 is okay. And it is all done on upflow. And so it is also very sure that all the water passes through all the filtering media, and there's a good residential time. So we have got 5% put on pre-process and the last stage, and 30, 30, 30. So this covers your 100%. For example, I'll give you an example. For example, if the CSE flow was 8 KL per day, we had it for about say 6 days. So 8, that means it comes to nearly 48. So made it 50, and this 50 KL will be the residential time. 50 KL with the residential time for primary tank, secondary tank, and tertiary tank, and with including of both the pre-process, and the post. So pre-process, process is doing into 3. So all done in these percentages, and it has worked very well. And you can increase and decrease by putting more stones and decreasing less stones. You can increase the volumes in the respective tanks. Okay, next slide, please. Okay, now we are coming. How are we on the time, please? How are you on the time, Niharika?
Yes, sir,
Niharika,
you
how are
can
you?
continue. Yes, sir, you can continue, sir. We have time.
Okay. Now let me put it down, because this way forward has been changed a number of times, and it is a lot of new jargons are coming. When we did the CSE plant and other plants in 2002 up to 2010, all this was not heard of. Now we have started hearing about carbon neutral, minimum footprint, minimum all this, things, and also greenhouse gas emissions, and circularity of process, life cycle analysis of water, and many other things. Like things have come in a campus. You got ZLD. ZLD means you got something like zero liquid discharge. That means they don't want your whatever is the water which we take from the municipal corporation, or from the tankers, or or sometime from the borewell. You're not supposed to pump out. You're not supposed to release to the municipal line. You're supposed to use it as much as possible. So that is the best. That is the best mode. So you whatever is the contaminants, whatever is the pollutants which you create, you try to clean it up as much as possible yourself, and you are the custodian of all the pollutants. So you make sure that the pollutants are all cleaned up, and all the sludges are all removed, and the reused water is also properly removed, and it is used in the campus. It can be done, because you have got if suppose you have any campus, you have got lot of greens. So this greens can be watered, and greens can be maintained, and many other say facilities can be made. You can have kitchen garden, you can have, say, terrace garden, you can have flower gardens, you can have for beautification, you can have nowadays the craze is built up to have a lot of say landscaping and nursery being properly done, to have a lot of indoor plants. The indoor plants, especially in NCR areas and other areas, have come up. So they like to bring a lot of indoor plants to purify the air inside inside your own homes, inside your own complex. So all these things require water. All these things require water, and good water. So this can be used. So when you make use of all these things, so ZLD, the part of it comes up. So we have ZLD, or you can use some of this water can be given away. Some of this water can be given away for reuse. For example, lot of industries and others, they buy water. They buy water from all these recycled outlets at something like 500 rupees per kl. 500 rupees per kl. All other places it may be a little bit more expensive, but they buy at this. And even the sludges, you should make sure that whatever are the sludges which are coming out can be co-composted in the campus itself, or it can be made like a compost, and you can release to a nursery and many other uses. So all these things in the last part on the left hand side. So it is something like a sustainable development, and full life cycle analysis is being done. So I will just quickly read through the some of the points given out in the 1, 2, 3, 4 phases of whatever we have picked up. Say incorporating advanced technologies for optimized waste treatment, a minimum space requirements, reducing environmental impact, utilizing natural processes to minimize energy consumption. This is very, very, very important. As a matter of fact, energy consumption in this DEWATS plant is very, very minimal. So you don't have to worry. So even if you have a power failure, in lot of STPs and others, by aerator is not working, my clarifier is not working, my other this other filters are not working, centrifugal filters are not working. So it doesn't happen because the water will flow. The water will flow naturally. Innovative design for GHG emissions during treatment, biochemical processes to ensure carbon neutral operation, contributing to a cleaner and greener environment, closed loop system. This is what we are trying to get at. Having your ZLD nowadays, in lot of campus and others, even ZLF has come. That means the ZLF means zero landfill. That means they don't use a dump site for solid waste and others to be going to landfills and others. They want to utilize everything. For example, if you have a construction and construction building, say works going on. So all that which is coming out of the construction, all the rubble or all the debris which are coming out, C&D waste which is coming out, is all used up. Is all used up within the campus itself, and none of the waste nearly go out. Even the steel cuts and metal cuts and glass cuts, they are all properly used within the campus itself. And so there's a lot of advantage, and you don't depend on anyone. You don't depend on anyone for any of these things. Okay, so we have got aligning all this sustainable development goals with eco-friendly uh, waste technologies, and of course, final thing is the compliance of the pollution control board. This Nowadays, you got NGT and pollution control board. They are all taking a lot of rounds and ensuring that STPs are really working, and we really have to ensure that STPs work very well. And you also have a lot of a public outcry in case you have certain STPs not working and it is polluting your neighboring environment and others. And of course, in the year 2018, 2019, we had the COVID era. And so in the COVID era, a lot of waste generators, they had to really wake up and make sure that totally whatever waste is being generated, it is kept within your campus. And if it is going to go out, it should be made sure that it is hygienically sanitary conditions are properly maintained and duly disposed of. And that all has to be made up. So a lot of municipal linkages also would be used in those, let's say, remedials and others. Okay, so we got water usage. I'm just this is just a data for those who are using water, and water for irrigation, water for gardening, water for, say, gardening of your grasses and others. So water usage for your green spaces. I just want to give a data. 1 square meter of well-grown grass or well-grown plants require 1 liter per day. 1 liter per day. And of course, this is all varying, efficiently utilizing treated water for various parks, lawns, and green areas, supporting lush landscapes. And you can have many people have got floating garden, a floating bed in garden, vertical garden, semi-vertical gardens. So all these are add-ons which help in maintaining the whole campus in good order. I think I'm coming to the end of the slides. Next slide, please. Okay. So I finish off with this thing. So those who are present over here, of course, you must have taken your own pledges and your own say commitments for doing lot of cleaning up Niharika, you will be able to compile up people who are wanting questions.
Include the cost, comparison cost, no, compared with the other treatment systems like ASP or BBR, like that. And we
See,
can also
our cost, for example, whenever you do a septic tank, see, most of the complexes or a campus or any other say organization, whenever they have a sewage, they always make a septic. They may always make a septic tank, irrespective of whether there is an STP or not. A septic tank is usually done. That's what I get to gather from the civil engineers' way of layout of various tanks and others. So when you do a septic tank, you just make sure that whatever the septic tank, you do it in such a way that it follows the DEWATS principle. That means if the flow is coming to something like 5 KL per day, 5 into 5 days, so 25 KL, and you put some other factor for putting all the filtering media and others, you make it nearly double. So 25 into 2, 50 KL tank you have, 50 KL tank you have, and this always helps. Because what happens is most of the campuses in the under the ground space is always there. Under the ground space is always there, and they can be made use of. And over the ground space is normal. So 2 meter level under the ground, if you have tank, it won't matter. Even around the foundation you can have safely done. This is what I gather. And also I have found that in certain complex in which I had done this same DEWATS STP, I had given over some say hydraulic capacity, and they found that literally around 10 KL or some 15 KL can be spared. It is much more. So they used up 10 KL and 15 KL for storing rainwater. So whenever rainwater is coming in the campus, they said, okay, we'll use that this STP, whatever you are given, something like that 5 times whatever is the flow you are given as the HRT, and that is the storage tank. That extra tank and extra storage capacity we have, we will use it for storing rainwater, and rainwater can always be used for secondary water or for flushing water, or in case of emergency, it can go into a water, because most of the homes they have AquaGuard and they have got RO system and others, because no home uses direct water from which is being supplied by the common supplier, because no one uses direct tap water. The tap water is always reprocessed in the home. Either they have an AquaGuard, or they have an RO system, or they have some other system to repurify the water and use it only for drinking and potable and cooking purposes. So it is fine. So we can use that rainwater in all the ways in these things.